Hello, everyone. My name is Mr. Lee, and welcome back to As Quickly as Possible, a series where we discuss math and science topics as quickly as possible so that you can get done with your homework as quickly as possible. This is part 4 in our series discussing trigonometry, so if you have not checked out parts 1 through 3, I will have those linked in the description so that you guys can check this out and get caught up so that you can understand what we're about to do. So today we're basically going to be solving another example problem, and this problem will be entirely law of sine, but we will also be using an inverse function within the law of sine too. So yeah, stay tuned for that. So the problem reads, two people are standing at opposing ends of a crooked flagpole from each other. All right, and this question has two parts, so I'll go ahead and read part 1. If person 1 is standing 5 meters from the foundation or the bottom of the flagpole and is looking up at the finial or the top of the flagpole at a 48-degree angle, and the angle from the finial, to person 1 is 30 degrees, how tall is the flagpole? What is the distance from person 1 to the finial? Okay, so part 2 says that assuming that the ground is completely flat, person 2 is standing 6 meters away from the foundation, and the distance from person 2 to the finial is 8.5 meters. What angle is person 2 looking to the finial at? All right, so if you have a keen eye, you'll notice that what I just read right here at the bottom of part 2, we are looking for a degree. We're looking for this degree right here, meaning that once we get to this part of the question, we're going to be doing inverse functions. So hold on to your hats for that one. Now, I know that the problem isn't asking to solve for all the missing variables that I have written down right here, but we are going to solve for those anyways because there are a few that we do need to solve for in order to solve more variables. So I figured we might as well go all the way on it. So before we move on, I do want to go ahead and quickly explain the concept of subscripts before we get too deep into this, because I know it can be confusing to see these little numbers down here in the little subscript section. So basically, a subscript is a number assigned to a variable that, let's say that we have these triangles split apart. We have the same variables for this and the same variables for that, but they're different. They're labeled the same, but they are fundamentally different variables. Therefore, the distinction is in the subscript. I didn't leave just normal b or normal lowercase c. I made sure to put the subscript 1 so that this could be explained a bit more clearly. But yeah, that's exactly what's going on here. So from now on, whenever you see within this video, whenever you see a subscript 2, I am referring to the variable that's in this right triangle right here to the right. It's not a right triangle, but it's the triangle over to the right. And if you see subscript 1, so like a sub 1, I'm talking about side A on the first triangle. And a sub 1 and a sub 2 are the same thing because these triangles are touching, but hopefully this will have more clarity once we actually dive into the problem. So if you remember from our previous video, I explained that the law of sine is basically sine capital A over side A equals sine capital B over side B equals sine capital C over side C. And this will be the same for triangle 1 and triangle 2 because these are oblique triangles. These aren't right triangles. Therefore, we need to use law of sine to solve for these. And if you remember from the previous video, I did plug in for these so that we could solve for these a little easier. So let's go ahead and start plugging in and see what we can find. So we got angle A right here, so we can go ahead and fill that out. So we got sine 48 degrees. And we do not have side A sub 1, so we can just put that right there. So A sub 1 equals, and then we got B. We don't have B, so we can just write down sine B. And then we do not have side B, so this will not be used. But we do have C, so we could put sine 30 degrees, which is what's right here, over 5 meters, which is what's measured or given for lowercase c, so we'll put 5 meters right here. All right, so from here we have this equals this, so this is the law of sine function that we can work with. So we got sine 30 degrees over 5 meters equals sine 48 degrees over side A sub 1. So now we want to get the variable by itself. We want to get it away from this division, so we'll multiply by a sub 1, and then that'll give us a sub 1 with a coefficient of sine 30 degrees over 5 meters equals sine 48 degrees. And now once we do that, we can divide this side by sine 30 degrees over 5 meters, and then do the same exact thing for this side, so that we get a sub 1 equals sine 48 degrees over sine 30 degrees over 5 meters. And once you plug this into your calculator, you're going to get around 7.5 meters, 7.4, 7.5 meters. I get 7.431 meters. So that's what we're going to go ahead and plug in for our side 1. So 7.431 meters. And like I said, a sub 1 and a sub 2 are basically the same exact thing. This is the flagpole. This is how tall the flagpole is. So these are touching right here, and these are the same length. So a sub 2 will also equal 7.431 meters. And this will be our given for when we start working on triangle 2. Also, if anyone was quick to notice, we can also solve for b sub 1 right here. In the previous video, I explained how all the angles within a triangle, within a single triangle, all of them will come together and add up to become exactly 180 degrees. So we've got 48 degrees for here and 30 degrees. So let's go and write that down. Add them up. 48 plus 30 degrees, that will equal 78 degrees. And then we take 180 right here minus 78, and that will give us 102 degrees. So now we've got b sub 1 equaling 102 degrees. And now that we have this angle right here and we don't have this side, we pretty much have every aspect of this left side triangle solved except for the hypotenuse right here, which is the distance from the finial of the flag down to the person 1 that's standing over here. So we can go ahead and break out law of sine again. So we'll do C this time. So sine 30 degrees, I'm pulling that from C right here, and C projected down to 5 meters. So C, or sine 30 degrees over 5 meters equals, and then we got b sub 1, which is 102. So we got sine 102 degrees, and then we got that over b sub 1 because we don't have it yet. So now what we do is we multiply b sub 1 on both sides. Right here, we got b sub 1 with the coefficient of sine 30 degrees over 5 meters equals sine 102. Then we do division right here. We divide this by itself to cancel it out. And then we divide this, what we do on one side, we got to do on the other. So what we end up getting is we get b sub 1 by itself, and then we got sine 102 degrees over sine 30 degrees over 5 meters. Right, and once you plug this into your calculator, you should get around 10 meters, but more specifically, you should get 9.781 meters. So that's what we're going to put for our answer. We got that the distance from person 1 over here to the finial of the flagpole, which is the very top, that distance is 9.781 meters. So we'll write that down for b sub 1, 9.781 meters. Perfect. All right, so now we solved the sub 1 brackets. We got all those variables solved for. We got b sub 1, capital B sub 1. We got the degrees for that, and we got the 3 measurements of these 3 sides right here. So what do we do now? Well, if you look over to the second triangle, we do have 2 sides, but we don't have any degrees. We don't have anything to work with the sine function, or so you think. If you were paying attention to the previous question right here, you would notice that at the beginning of part 2, it would say that assuming that the ground is completely flat. Now, with a straight line, when you have a straight line, the degrees on the top and the degrees on the bottom will both total 180 degrees. That's why a circle is 360 degrees, because the circle is all completely around the flat line, and a flat line is only half of a circle. Therefore, it would have half of the degrees of 180 degrees. That means that when we go to the bottom of this triangle right here, where these two meet, This right here will all total 180 degrees, but we already have B sub 1 right here, which is 102 degrees. So if we do some simple arithmetic, we take 180 minus B sub 1, 102 degrees, and we subtract that, and then we get 78 degrees. Therefore, B sub 2 will equal 78 degrees. Now then, this gives us a whole lot more breathing room. This gives us some stuff to work with. Now we have two sides and we have one angle, meaning that we can fill out one part of the law of sine equation and we can fill out half of the other one, which is basically what we need in order to solve for the law of sine problem. So now what we do here is we write it out. So we got sine a sub 2, because we don't know what a sub 2 is, but we do know what a sub 2 is for the side, because we already discussed that the side here, a sub 2 and a sub 1, are of the same line, therefore they have the same measurements. So we write that down, 7.431 equals, and then we take our given, so we take sine 78 degrees, and 78 degrees right here projects out to 8.5 meters. So from right here, we are able to cross multiply. If you have the law of sine written out like this, equals, etc., we can take the denominator right here of the left side, multiply it to the numerator on the right side, and we can take the denominator of the right side and multiply it up to the numerator of the left side. This will all come to total 8.5 meters sine a sub 2 equals 7.431 meters sine 78 degrees. And now you may be wondering why exactly I chose to cross multiply, and this will become clearer here in just a second. Just stick with me, and we will get through this, I promise. So divide by 8.5 meters. 8.5 meters. You want to go ahead and cancel that out right there so that we get sine a sub 2 by itself. And then we got that equaling 7.431 meters sine 78 degrees. Got that over 8.5 meters. Now we got the variable separated from all the constants over here. We just have a function that's attached right here to the variable. But this is good news because this means that we can actually bust out the inverse function. So basically how this is going to work is we take arc sine or inverse sine. We make the parentheses real big because we're going to fit this in over here. 7.431 meters times sine 78 degrees, all of that over 8.5 meters, equals a sub 2. All right, and once you type this into your calculator, you should get something around 59, 58-ish degrees, but if you want to be specific, like I always like to do, you'll get 58.774 degrees. So that's what a sub 2 is going to equal. It's going to equal 58.774 degrees. All right, so the last thing we got to do is we got to solve for c sub 2 right here, this angle, which is pretty easy right now because we actually have this angle and we have this angle now, and all we have to do is add these two together and subtract it from 180. So that's what we're going to do now. But I do not want a crazy decimal number in my arithmetic right here, so I'm just, for simplicity's sake, we're going to take a sub 2 and we're going to round it up to 59. So we got 59, and then we're going to add that to b sub 2. So 78, and then we get 137. We take that, we take 180 minus 137 degrees, and then that'll give us 10, 3, 7, 4, 43 degrees. So c sub 2 equals 43 degrees. All right, now you see we've gotten all the variables that I've written down over here solved. So let's go ahead and check our work. Let's go ahead and read the question again. This is really important. Let's go ahead and read the question again and make sure that we answered everything. So let's go ahead and reread the problem and go from there. So problem was two people are standing at opposing ends of a crooked flagpole from each other. Part one said if person one is standing 5 meters from the foundation, which is our given right here, the bottom of the flagpole is looking up at the finial, my bad, the finial or the top of the flagpole at 48 degrees, which is another given. That's the angle of the perspective right here from person one. All right. And the angle from the finial to person two or person one is 30 degrees. How tall is the flagpole? So we got the 30 degrees given right here. And we are also asked about the height of the flagpole, and that's what we solved for a sub 1 and a sub 2. We already solved that, so 7.431 meters. That's how tall the flagpole is. What is the distance from person 1 from the finial? So we also solved that as well as b sub 1. That's our distance, which is 9.781 meters. All right, now we can move on to part 2. So assuming that the ground is completely flat, person 2 is standing 6 meters away from the foundation, and the distance from person 2 to the finial is 8.5 meters. What angle is person 2 looking to the finial at? So basically all it's asking is for a sub 2 right here. So that's what we solved for. A sub 2, we got 58.774 degrees in our calculations when we did the inverse function. And that is the degree at which person 2 is looking up right here to the finial of the flag. So in essence, we have the entire problem solved as of now. All right. I hope you guys learned something and take it easy.